part one, we looked at whether the given production function exhibits decreasing returns to capital. We want to now check whether it is characterized by constant returns to scale or not. So I want to do part B. So first, let's recall what do we mean by constant returns to scale. So recall constant returns to scale means if we scale all inputs by some amount, so the key is all inputs by some amount, output gets scaled by that same amount. So here, just before we check whether it exhibits constant returns to scale or not, we need to remember in returns to scale, we're changing, we're scaling up or down the entire production process, we're changing all of our inputs. But when you look at returns to factor, like in part one, we looked at returns to capital, in that we're only changing that particular factor of production and keeping all else fixed. So how do we check now constant returns to scale? Checking constant returns to scale. So now the approach will be, we will change both inputs, both N and K. N and K by lambda and see does Y change by lambda or not. In short, is F N, sorry, in short is equal to lambda F N K. So we want to essentially check this, that if we scale both of our inputs by lambda, does our output gets changed, does our output get changed by lambda or not? That's what you want to check here. So let's check it for this particular production function. So let's just do that now. So initially we know, so to begin with, initially, so we're given y is equal to f kn is equal to k1 by 2 and 1 by 2. This is a production function. Now let's scale both inputs by some multiple lambda. So then when we change both inputs by some multiple lambda, so we know that k is being changed by lambda and n is being changed by lambda. So instead of k, I'm going to write lambda k over here, and instead of n, I'm going to write lambda n. So let's just open the powers up. So we know, okay, this is a rule of exponents that, you know, when you have, for example, so this is a rule of exponents that if you have ab to the power n, you can write it as like this, right? You can distribute the power over products, right? So this is a rule of exponents here. So then this becomes, so based on this, you can write this as lambda 1 by 2 k 1 by 2. Similarly, you can write this as lambda 1 by 2 n 1 by 2. We'll apply another rule of exponents here where we know, okay, when we have a n and a m, so we know, okay, when you multiply like bases, you can add the powers up. So a n plus, so let's apply this rule of exponent here. So this will become lambda 1 by 2, lambda 1 by 2. Let's just first write them together before applying this. So then this becomes lambda 1 by 2 plus 1 by 2, because when you have the same base being multiplied, you can add the powers up. And this is just k 1 by 2 n 1 by 2. This can be written as lambda k 1 by 2 n 1 by 2. And what is this? This is just equal to lambda f k n, and this is just y. right? So we have seen okay, when we scaled both of our inputs by lambda, our output also got scaled by lambda, right? So this is just equal to lambda y. So this is equal to lambda y. Right. So the production function satisfies constant returns to scale in this case.